Okay, everybody, let us see if this one can work off my window seals. Looks like it's still working. Okay, so this is SpaceX. It's the Dragon. It's the cargo shipping that attach itself to the ISS, the International Space Station, and they deliver astronauts or deliver goods, suppliers, so that the International Space Station can sort of maintain and survive with all the people on board. So what I did, it showed the latitude and longitude where the cargo is at the moment. It is connected to the ISS, so it might look boring because it's actually flying at the same coordinates and the same distance as and the same speed as the International Space Station because it's attached. But the reason why I did this is I'd like to see when it detaches itself and when it reattaches itself, because it's obviously it's supplied till a certain point and then it comes back to Earth and then it flies up again and reload and upload and download and so on. So I found it quite interesting, and it might be a bit boring because it's the same speed and the same coordinate as the ISS. But yeah, the codes, and this project does not run via NTP. It runs directly via the GPS. So the GPS will show my coordinate to the calculation to find out where the distance, how far it is from me. And you can see from the latitude of the latitude of the Dragon, Dragon 31, CST 31, from its latitude and my latitude and longitude, I will calculate the distance, how far it's moving towards me. Okay, so, and remember that this runs, you're going to need a GPS in this case. Okay, this is a nice GPS, same principle as the other one. Let me show you the LCD. It's the 1602 and it's I2c. The pin, it's D1 and D2. So D1 is LCL, and SDA it's D2. SDA D2 and LCL it's D1. Then you have the pins of RX. On the code it says RX must go to D6 and TX goes to D7, which is correct because it's a virtual serial, but then you swap the pins, otherwise it doesn't work, as we discussed this long time ago. Okay, so there we are. This is the codes. You need to upload all these library, which you do have them on your Arduino IDE. TinyGPS, which is ++, which you have to upload this one. I'm sure you have already all the other one. And SoftwareSerial. The SoftwareSerial is because you cannot use the GPS RX and use the RX and TX on the ESP32 or any microcontroller, because you would have issues with your USB. Okay, so you have to have a software serial set up so that the pins that you choose, in this case, the pins is D6 and D7. Okay, as you see them here, RX is D6, TX is D7. But on the board, these two pins need to be swapped where Rx will be on D7 and TX will be on D6. That's the way it works. Okay, so here we have, okay, this one we can take it off after. Please do not use it. It's my API keys. You will have to go and get your one. This is the satellite IDE. In this case, it's a SpaceX Dragon CRS 31 satellite cargo. It's just a cargo ship that attaches itself to the space station, deliver goods and astronauts, and then moves away again. But it's still attached at the moment, so you can enjoy a free ride. You'll see the latitude and longitude. This is my latitude as well. It is being taken from the GPS, so you don't. GPS will know when you take it out. It will know your one, and it will work it out. This is the website, the N2O, and yeah, and then you know your HTTP client, the way it works. And then we have the latitude. Is going to work out all the latitude here. The speed is set up. The speed is constant. It's 7.66, doesn't change. Well, I had an issue to take out some information from the API, so I just put it manually here. But you know, you don't need to have the speed. It's relevant. Speed, it's always the same. You might have change when the rocket is pushing it from the Earth into space, and then when it goes back. Okay, so the JSON parsing, you know, you do parsing from the HTTP client, and here it's you initialize the LCD, and here you initialize the Wi-Fi. Yeah, you need to, yeah, you will have a wire begin. In this case, it's D2 and D1. And LCD begin 16,2. That's normal. And it will print CR. I just said I didn't want to put Dragon. It's too long. So I just put CRS SpaceX 31 in it, initialize. And so on. And yeah, here we have the you know, latitude. This is a latitude print on the which will appear on the LCD, and this is the latitude in value that will appear. This is a longitude, and this is the last latitude and the last longitude. Speed. Last speed, distance, and okay, the distance you need to calculate with this formula here. Okay, so you need the distance as a float, obviously, because it's a decimal. You need to give the radium of the Earth. It's a, you know, in this case it's spherical, but it's flat, round. It's this is 314 pi. It's not 628. Okay, so here it's LCD cursor and 0. You know, we discussed this before, how the cursor works. 0, 0, it's a top, and 0, 1, it's a bottom. So the latitude will appear on the top. The last latitude with a 2 decimal, it's the value. And this is where, again, where you want the longitude to appear, which will be 0, 1, 1, which is at the beginning of the block and its second line. And it will show L or N, and then the value, last longitude with 2 decimal. And here we will have the distance, last distance in kilometers, to the CRS SpaceX, which is from your coordinate, from my coordinate. It's the same in kilometers. Serial, we can go and, yeah, and the calculation. It will calculate the distance from my position to the position of the SpaceX Dragon. Okay, so there we are. All right, quite intense. And then I can see I'm using this one and it still works. It's something that I manufacture. Okay, I put the wire because for some reason it never works if it's not on the window sill. And you can see that it's when this light is flashing, it means that you have it is working. It's actually calculating data. Okay, guys, I hope you enjoy this. Please give me a thumbs up if you like it, and have a fantastic Monday. Thank you. Bye.